Hi and welcome to the fifth part of this Unity for Beginners course. So at this point we have covered a lot of ground. We have created two C# scripts. We created a script containing code so that the main camera follows the movements of the player, gameObject, at a predefined offset position relative to the player gameObject. We also created a script named PlayerMovement that is attached to the player gameObject. This script contains code that enables the user to control the player gameObject, movements through three-dimensional space on the ground plane. This script also contains code that enables the user to make the player gameObject jump. This jump action is going to become very handy in this part of the course, because in this part of the course we are going to add obstacles to the ground plane. In order for the player gameObject to traverse the ground plane, the player gameObject will need to jump over some of the obstacles placed on the ground plane. If you like this video, please hit the like button and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description of this video. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comment section. If you have any questions about the course or any aspect of the course, please feel free to ask any questions below in the comments section. Let's start by extending the ground plane on the Z-axis. So let's set the Z-axis to 1000. Great! Let's reposition the player gameObject so that it is placed near to the beginning of the ground plane. And of course, make sure the camera is positioned at an appropriate position behind the player gameObject. Select the camera in the hierarchy so that you can view what the camera is picking up. So our obstacles will simply be 3D cube objects that Unity provides for us. So let's add a cube object through the Unity editor like this. And we can place the cube on the ground plane at a position of our choosing. So I'll place my first obstacle at this position on the ground plane. We are also able to scale our obstacle appropriately like this. Let's run the game. Great! And we can jump the player gameObject over the obstacle. Excellent! Let's name the cube that we have just placed in the scene, obstacle, in the hierarchy window. So we want to add multiple obstacles like this one to our scene. To do this, we could simply add multiple cube objects individually, the way we added our first cube object to our scene for this purpose. But we want to categorize, if you like, all of the obstacle gameObjects under one type, as it were. So how can we do this, and why do we want to do this? We can do this by making the gameObject a prefab. The advantage of doing this is, for example, if you wanted to change the material on one of the obstacles, this change in the material will propagate to the other obstacles in the scene automatically. So by creating the relevant prefab, you don't need to, for example, change the material for each obstacle in your scene individually if you want to change the materials for all the obstacles. You only need to change the material for one of the obstacles, and the change will propagate through. All you have to do is open the prefab and change the material. We'll do this a little bit later in this part of the course. So essentially, we are making a gameObject a reusable asset by making the relevant gameObject a prefab. If you'd like to read more details about prefabs in Unity, please navigate to this URL. So in order to make our obstacle a prefab, we can simply drag the cube that we just added to the scene from the hierarchy window anywhere within the assets folder. So for organizational purposes, let's drag the obstacle game object into the folder named Prefabs, which is a child folder within the assets folder. So now to add our obstacles to the scene, we can simply drag and drop the prefab onto the scene like this. And we can position and scale each of the obstacles accordingly. Note, in order for you to effectively design your scene, you can get a bird's eye view of the ground plane like this, which helps you get an overall picture of where the obstacles are placed in the scene. And of course, we can get as creative as we like in designing our scene. We can make some of the obstacles taller than the other obstacles. We can make some of the obstacles take up most of the x-axis, so the player is forced to jump over the obstacle. And some of the obstacles can be scaled in a way that the player can move around the obstacle. Perhaps the obstacle is too tall for the player to jump over it. So as discussed earlier, we can change the material for the relevant prefab, and this change will propagate through to all the other obstacles. So we are going to just create a basic material here. Before we create a material, let's see what the Unity docs say about materials. So let's navigate to this URL. To draw something in Unity, you must provide information that describes its shape and information that describes the appearance of its surface. You use meshes to describe shapes and materials to describe the appearance of surfaces. So let's create a material. To do this, let's right-click inside the Materials folder that resides within the Assets folder. Then from the context menu, click Create, then Material. Let's name our material Obstacle Material. We'll look at how to use more complex materials later in this course, but for now, let's create a very basic material, and let's change its color like this. Then to add our new material to all of our obstacles, let's open the relevant prefab like this, And we can simply drag and drop the material file onto the prefab like this. Great! Let's add a material to our player game object so that it stands out. So when the player game object hits an obstacle, the player's energy level is decremented by a value of 1. We'll later configure the player game object to start with an energy level of 5. If the player's energy level hits 0, then it's game over. So firstly, we need to detect when the player game object collides with an obstacle. We can achieve this by implementing code for a method named onCollisionEnter. Note how we use the tag property of the collider component attached to the game object, with which the player game object has collided, to assess whether or not the player game object has hit an obstacle. Let's create a tag through the Unity editor named obstacle. So let's add the obstacle tag to the first obstacle. Note that this does not add the obstacle tag to the prefab. We'll do that a bit later. We want to write the energy level value that is decremented as a result of the player crashing into an obstacle to the console window. Let's define a variable named energy level, which is of the int data type. So we can decrement the energy level value through this line of code. We can then write its value to the console window through this line of code, debug.log energy level. So let's run the game, and if we jump over the first obstacle and bash into the second obstacle, of course nothing happens. Nothing is logged to the console window. Why is that? This is because we haven't added the obstacle tag property to the prefab. We only added the tag property to an individual cube object that represents the first obstacle. So if the player game object had crashed into the first obstacle, our code to decrement the energy level would have fired, and our code to write the energy level value to the console window would have also fired. So in order for this code to fire when any obstacle is hit, let's open the prefab like this and add the obstacle tag property to the prefab. Now when we run the code, we can see that the energy level value is logged to the console window, and you can see that it has been decremented from 5 to 4. Great! Let's create code so that when the energy level value is equal to 0, that the text game over is written to the console window. Let's say we also want game over logged to the screen when the player game object falls off the ground plane and falls past a point on the y-axis. So we are going to say that when the game object falls past -10 on the y-axis, that it's game over. So we only want game over to be displayed once in the console screen, rather than repeatedly. Because remember, the update method is repeatedly running. So we can use a Boolean value to flag when it's game over. And we can restructure the conditional code like this, so that game over is only written once to the console screen. Excellent. In the next part of this course, we'll code a stopwatch timer that will be displayed at the top of the screen, so that the user can see how well the user is doing. When I say user, of course, I mean the person playing the game. Remember, the main objective of the game is to get to the end of each level in the fastest possible time. If you liked this video, please hit the like button and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description of this video. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. If you have any questions about the course or this particular video, please don't hesitate to ask me below in the comments section. I look forward to seeing you in the next video. Thank you and take care.